Dear learners, I am Dr. B. Kavita, Assistant Professor in the Department of Physics from JVG Visalakshi College for Women, Woodmanpet. Today, we are going to see about the introduction to the elasticity in the properties of matter. Yes, today we are going to see about the elasticity, introduction to the elasticity, then what is meant by stress, then different types of stresses, introduction to strain, then different types of strain, and how these stress and strain involve in the elasticity and plasticity nature. And from this, we are going to derive the Hooke's law. Yes. First, we are going to see about what is meant by elasticity. Elasticity is the property by which the material regain their original shape and size even after the removal of deforming forces. Yes, when an external force acts on a body or a material, we can say sometimes it is a material and sometimes as body, a material, there is a change in their length or their shape, volume, whatever may be. Okay, that means that it gets strained, the material gets strained. Okay, so due to that strain, what happens is the elasticity may be varied. The elasticity may be varied and it prolonged to some extent. Even from we are giving more and more forces, it will prolong to a particular length or particular volume. There will be change, it goes there. But at a particular time or a particular force, what happens is the elasticity nature gets destroyed and there comes the plasticity. Okay. When the external force is removed, the body regains its original shape and size. That is called as an elasticity nature. And if we do repeat this thing the same again and again, so the elastic body nature will be destroyed. Yes, the best example is steel, quartz material, or sometimes or the elastic materials. Yes, we can still we can bring it to a, if we heat the material, it loses its atomic forces and it becomes very loosey and we can mold it to some other shape. And again, if we heat it, if we now it becomes a new shape. If if we again heat the material, steel material, then we can bring it to the same shape or to the some other shape. So it is called as an elasticity nature. So the opposite of elasticity is called as plasticity. That is, no substance will be perfectly elastic. That is the problem. Or perfectly plastic. Okay. Now you can consider this a rubber band, what we use for packing our things. If we extend to some other extent, it will, yes, it is prolonged. Yes, it is tensile or it is changing its length. Sometimes it's changing its volume. Yeah, you can see, I think it extend to some other extend, it's going on extend. If we extend more and more, we are giving force. We are removing the force. What happens? It comes to its original position. Comes to its original position. Again, I'm giving force. It is moving to the some other places, or it will moving the shape and size has been varied. And again, now I'm removing the force. It will comes to its original shape. And now, if we repeat the same thing, what happens that it gets destroyed. The elastic nature gets destroyed. Okay. So this is the introduction about the elasticity. Okay. So now we are saying that we are giving force. Okay, force that is applied to this material. And this point is called what's the force applied to this material at a particular area is called as stress. Called as stress. Yes. So stress is when a force is applied on a body, there will be a relative displacement of the particles. Relative displacement of the particles due to the property of elasticity. Okay. So whatever, if we remove that force, it regains to its original shape. Yes. Now you see this is a rubber band. It is composed of atoms. Okay. Yeah. Now I am applying a force to this. What happens is that the particles or atoms is displaced. If it is there, now it is moving to some other place. So it gets displaced. Okay. So due to this elastic property only, it will happens this. It will happens this. After remove this, it will come to its original position. So stress is defined as that force is applied, a restoring force applied to a particular area in a material. It is called as stress. So here we can see the force is applied to that particular area in this cube. we are applying in the upper surface of the cube. So a force is applied to that particular area, that is called as a stress. Yes, we are having two types of stress. Okay, what are they? That is normal stress. Another one is a tangential stress. So what is meant by normal stress? Normally it happens. Yes, the restoring force applied to that material is perpendicular to the surface. It is perpendicular to the surface. See, this is the material and we are perpendicularly applying the force to that material. That is called as a normal stress. And we are moving to the tangential stress. So just opposite to the normal stress. Yes, the stress we are applying to the force applying to the material which is parallel to the material, that surface of that material. That is called as a tangential stress. Okay, both are stress, but in what direction we are applying the forces differentiate the types of stresses. One is normal stress, which is perpendicular to the surface of the material, and tangential stress is parallel to the surface of the material. Okay, so what will be the unit for this stress? So force by unit area, force by area. So force, which is maybe Pascal, or we can say it's a Newton. Newton. Okay, area, which is in meter square. So the total unit is Newton per meter square. Newton per meter square. Okay. Next, we are going to see about the strain. Okay, so we are saying that we are applying a force. Elastic nature is nothing but we are applying a force to that material. It gets elongated or compressed. There will be change in the material. If you remove that force, it comes to its original position. So there is a change in the length or volume, we are saying that. So that is called as strain. What we are applying the force is called stress. What is the change is called as strain. So strain is the deformation per unit length. Deformation per unit length. If it is length, if there is a change in the length, it is called as a longitudinal strain. If it is change in the volume, then it is called volume strain. If it is change in an angle, that is, we are for an example, shearing strain, we can say we are taking a rod and we are holding it hold at rod at one end, and we are giving a sharing stress to that material on the other end. What happens that we are forming an angle theta, that is called as a shearing strain. Yes, both the stress and strain will form you the elasticity, that comes the Hooke's law. So Hooke's law or elasticity, we can say it is a stress by strain. Hooke's law is nothing but stress by strain. Okay. So we are having two types of stress and three types of strain. So if we are applying a normal stress and there comes a longitudinal strain, then that is called as Young's modulus. That is called as Young's modulus. If there is a change, we are applying a normal stress and there comes a change in the volume, then that is a volume strain. That is, we happens at volume strain. So normal stress divided by volume strain is called as a modulus of elasticity. So rigidity modulus. The modulus name is rigidity modulus. And the last one is, if I are applying a tangential stress, there comes your shearing strain. Then this type of is called as a rigidity modulus, or we can say it is rigidity modulus of rigidity or rigidity modulus. If there is a change in volume to that original volume, that is called as a volume strain. So normal stress divided by volume strain is called as a bulk modulus. Sorry, it is called as a bulk modulus. Okay, so that's all about the about elasticity and stress, different types of stress, strain, and we are taking up depends on the stress and the types of strain, and we are defining the elasticity modulus of elasticity, that is called as Young's modulus, that is the change in length, normal stress divided by change in length, and bulk modulus, normal stress divided by the change in the volume, and the rigidity modulus is the tangential stress divided by the shearing strain. So these are the different types of modulus of elasticity. In the next class, in the next lecture, we can see about the what are all the experiments will be carried out for based on this introduction. Thank you.